All right, so welcome to our final online get together here. This is going to be mostly just kind of a wrapping up of any details, answering any questions that folks might have, um, and kind of providing a few resources that might be useful to you at this stage in the program. First thing that I'm going to do is I'm going to post a link in the chat over here to a presentation that I put together. It'll look pretty familiar. It's really just information from some of the previous presentations that I've done for these meetings, but it'll also provide you with links that you might find useful. So I'll share my screen as well. So you can just look at it on here if you want, or you can go onto the actual presentation that I just shared in the chat. All right, so here we are. On the program timeline, we are now at the 4th online meeting. The last milestone or two will be the finishing of the engineering models that you will be putting together. And then we're going to be building those and testing them. And by January 15th, we expect to have everything built and tested and ready for flight. We still don't have a definitive launch date after Blue Origin's last flight, where they had to test their launch abort system because their rocket had a malfunction. They've been doing all sorts of investigations into what went wrong, and so they didn't tell us that it was going to be delayed, but I would be very surprised if it wasn't delayed. When you lose a rocket, there's a lot of work to be done to figure out what went wrong and how to prevent that from happening in the future. And especially since they focus so much on crewed flights, I imagine that they're spending a lot of time making sure that nothing like that happens again in the future. So we will be flying aboard their new Shepard rocket. We have in the past as well. We're going to be flying what's called a nanolab. And a nanolab is what they call the enclosure, their 2U CubeSat enclosure. And we have 4 of those, which will be going inside of their payload locker. There will be 12 nanolabs altogether. This is what I have planned for the actual CubeSats that will be going inside of each of those nanolabs. I tried to make them as similar as possible. Originally, what I had done was I was going to make like each CubeSat its own individual, kind of have its own role. Like one of them was going to have mostly Geiger counters in it, or 2 of them were actually going to each have 2 Geiger counters apiece, and that was going to be their main focus. And then there was going to be one that was going to be mainly like an environmental sensor, like temperature and air pressure and such. And then one was going to be mostly about like sound level as well as a microphone. What we've learned though, we did some 0G flights last month, and we flew 6 1U CubeSats. And what we learned was that redundancy is important. We had one of our cubes malfunction during the flight, and we also had backup cubes as well, which were left inside of a carrying container on the flight. And then we had one actual working fully cube that was able to be used to collect data. And so if we didn't have those backups, we wouldn't have had data. And I'll share that data with you guys so that you can take a look at it. There's some pretty interesting conclusions that can be drawn from it, as well as some interesting questions that we still have. and I'll go over that a little bit at the end. But these are the cubes themselves. I made them so that they're as similar as possible. And if you look at on here, you could actually click on each of these is a link, and it'll bring you to the page for that particular sensor. Something that I just want to make sure that everybody is familiar with. If we click on one of those, most of these websites, whether it's Adafruit or DF Robot, they have Wikipedia pages, or wikis they're called, or guides on the page where you would buy the sensor. And these are extremely useful. So like this is for the MPU 6050. This is the accelerometer gyroscope that we're using. And they have all sorts of information about the sensors, as well as like pinouts, so like where you plug things in, code and such, libraries. And so this is all extremely useful, especially if you're having difficulty getting something to work. I'd highly recommend going to the guide or the wiki on the manufacturer website. So at this point, we're in engineering model build phase. So, you're going to take the logical designs and the wiring diagrams that you've already created and submitted, and you're essentially going to now put that all into practice. So, utilizing the kind of model that we've been using throughout these meetings, we're now entering the kind of things have been figured out. It's not so crazy anymore. We kind of got this straight line here at this point in the process. Hopefully, if you're not quite there yet, that's all right as well. If you're still working on your wiring diagram or whatnot, or on your sketches, your code, that's fine. If you need any additional help, you can always reach out. We can schedule meetings with me and you, or me and you and your class, can answer any questions that you might have or your students might have. I'm here for that. At this point, with the engineering model build, you will essentially have a working CubeSat. So what we would like for you to do then is to put it into action. Test it out, collect data, look at the data. You might realize, oh, you know what? I need to change this bit of code here, to optimize things. And then ideally you'll share that data with us, especially, but also, with your students, other students in your school, your district, your community, so that they could see the results of all this hard work that you've been putting into all of this. This is something that I covered at the last meeting, but I think it bears repeating, which is sensor quality. We've learned a lot ourselves from the beginning of the summer workshops to up to this point now. And we're still learning that the quality of your sensors makes a huge difference. It's, it's definitely a big temptation to go onto like AliExpress or Amazon and try to get, the cheapest sensors that you can find, so that you get more of them, or maybe you just don't have a lot of budget. But we have definitely found that you get what you pay for when it comes to these Arduino sensors. And in most cases, if you're, spending, less than $1 on a sensor, there's a good probability that you might run into issues with it, not working or conflicting with other sensors. So we definitely recommend going for, spending maybe a few dollars or more per sensor as opposed to a few cents. These are some examples of sensors that we're actually going to be using. The environmental sensor on the right, specifically from DF Robot. It is a Chinese company, but it is the highest quality that I've seen from any Chinese companies. So I do recommend them. And on the left there, you have Adafruit Sensor, which is an American company. They are based out of New York City. A good thing about that as well, beyond just generally improved quality, is that if you order things from them, you'll get them in like a few days. Whereas if you order things from DF Robot directly from China, it can take a week or more to get it.
And Noah, just to let you know, this is Kathy here.
Mhm.
Eight, Adafruit actually will take a PO,
Okay.
whereas DF Robot and stuff won't.
Okay.
Or at least it's a lot more complicated. So my business office liked the Adafruit a lot better.
Okay.
So
That's a really good point. Yep. Yeah, it's substantially easier dealing with them because they're here right in America, as opposed to having to communicate, somebody in China. I have found that DF Robots troubleshooting is actually pretty good. So like I had some questions. Wasn't able to get something to work a while back, and when I would email them, they would email me back pretty quickly. Um, so that is a positive about them. Whereas Adafruit, I actually did run into a little bit of trouble trying to get them to help me troubleshoot things. So that's maybe a little bit of a trade-off there. It might be easier to deal with Adafruit, and it's faster most of the time when it comes to actually getting things from them. But in my own personal experience, and this is an anecdote, it might not be true for everybody, but in my personal experience, I did have trouble with them providing me with help when it came to something not working. So very important about sensors, and you will most certainly run into this with these experiments, is the way that the sensors communicate with the Arduino itself. Most of these use the SDL or SDA and SCL pins on the Arduino, and those two pins are for what's called the I2C protocol. And I2C is essentially a way of getting a bunch of different sensors to communicate with the Arduino using the same two pins, the SCL and the SDA, which is good if you have a lot of different sensors because you're not taking up all the pin slots on your board. Um, but the one issue is that using that protocol means that sensors have to have unique addresses. And for whatever reason, I don't understand why this is the case. Manufacturers, in some cases, will assign the same address to different sensors. In particular, I've run into this problem using the accelerometers and the micro SD card readers. For whatever reason, from multiple manufacturers now, I've run into those two, you know, parts having the same exact address. And so when you try to run them at the same time, they don't work. They conflict with each other. When that happens, if this is one of the primary reasons why I recommend using the higher quality Adafruit or DF Robot components, because they take that into consideration and they provide on the backs of those chips a two solder pads that if you solder them together by just putting a little blob of solder on there, it connects those pads and it'll actually change the address. So instead of, here for on the left side, you see it says actually on their default I2C ADDR address 0x68. If you put a blob of solder on the AD0 pads there, it'll change it from 0x68 to 0x67. Um, Same thing on the right side there. You can see that you have those options to change from 77 to 70, or it starts at 76, but if you connect the pads, it'll go up to 77. And likewise, it'll start at 53 for the other sensor on that chip and change it to 52.
No, do you know which is which here, the Adafruit, and which is the
Yeah, the left one is the Adafruit, and the right one is the DF Robot. They're the same. Pretty sure they're the same as what I previously showed you. No. So on the left here, this is a BME 280, which is pressure, humidity, temperature, and then here it's that it's the gyroscope instead. But they're very similar situation. Both of them have this functionality. So also in this presentation are those links to those suppliers that I definitely recommend. So Adafruit, Arduino, and DF Robot are the top three in my opinion. Just because I'm familiar with them, I've worked with them, I've troubleshot issues that I've had with their stuff, and I've been able to get things working. And they generally provide that functionality where you can change the address. These are some others. I haven't personally purchased anything from them, and like DigiKey isn't a manufacturer; they're a distributor, so you can actually purchase like Adafruit and Arduino branded products through them. Same thing with Mauser and Parallax. SparkFun is an actual manufacturer. I haven't personally used very much SparkFun stuff, but I know from their reputation that they provide high quality parts. They're also based in the U.S. They're based in Colorado. So if you're out west, it might even be faster to get things from them. So we ran some tests of CubeSats on our zero G flights that we did last month. And this picture actually is a link to that data. It takes a little while to load up because there's just so much data in these sheets. So don't be concerned if it seems like it's frozen on you. It's just there's so much in here that it takes Google a little while to load it up. So I wanted to show this to you so that you can kind of get an idea of how you can take the data from your experiments and manipulate it and show it in a graphical format. So this was from our November 14th flight. This page right here is actually from a website called FlightAware. Pretty interesting website that gives you all the data on the flight itself. So we had 6 CubeSats, and if you look at that picture, you can actually see them in the background. They're Velcroed to the wall at that point in the flight. Eventually, they were removed and they were strapped to our participants, and they were floating weightlessly. But they were recording all sorts of different types of data. So pay attention to line 1 in each of the tabs because it has some notes. So here for cubes 1, 2, and 3 were based on what we used in the workshops. It wasn't all of the sensors. Like we didn't use the UV sensor because it didn't really make sense. We were going to be inside of an aircraft the entire time, so there shouldn't have been any UV to detect anyway. So the sensors from the original workshop cubes that we did have on board were temperature and light. So cubes 1 through 3 were those, and then cubes 4, 5, and 6 were an updated version that actually use Adafruit and DF Robot sensors. And they're able to pack way more sensing equipment into the same footprint. So that's why we wanted to test those out. Unfortunately, due to the quality control issues of those temperature sensors on the workshop cubes 1 through 3, you can actually see how, for whatever reason, the data that we collected from them was all over the place. You can get a general sense of what the temperature was on, say, like cube 3 is this brown one, but you can see like the readings were going pretty haywire. If you actually look in the data, you'll see occasionally numbers with asterisks next to them. The reason those are asterisks are there because those were actually negative readings. So like for whatever reason, cube 1 second was at 19.75, but then it dropped down to negative 17, which doesn't really make any sense why that would happen. So what I did is I did a find and replace of all of the negatives and change negative symbols into asterisks. And what that does is it removes it from the graph, because the graph doesn't see that as being a number anymore. And so it just doesn't show it. Otherwise, this graph, before I did that, was just like a solid block. And it was you couldn't see anything else besides just a big brown blob, essentially. But you can see that cubes 5 and 6 did give us good readings. Now, the reason cube 4 isn't on here is because about 25 minutes into the flight, still not entirely sure why, but cube 4 malfunctioned, and we weren't able to. We were able to collect data from it, but it was very, very wrong data. Like, it was like saying that it was like 300 degrees Celsius, which it definitely was not. And so what that did with the graph is it threw the entire graph off, and you could barely even see any of the other readings because they were so far down on the graph, because the graph was going from 0 degrees all the way up to 300 degrees. So I just completely removed cube 4 from the data set, so that we could actually see some data. And now the reason why cube 5 and 6 are so different on this graph was because cube 6 was one of our backups that stayed inside of the carrying case during the entire flight. So you can see that they're pretty much the same up until this point right here, where the cube 5 was removed from the carrying case. And so now it was exposed to the air-conditioned air inside of the flight cabin, whereas cube 6 was inside of a case the entire time. It was actually warming up the whole time because it had those electronics going, which were producing a very small amount of heat, but it was an insulated case with a bunch of foam padding in it, so it got warm up until the case was opened up again to put cube 5 back in there. And you can see that at that point, all that hot air was released, and so the temperature went down. And then on cube 5, it started to warm up itself. Feel free to go through these tabs. Most of the tabs only have data from 4, 5, and 6 because cubes 1 through 3 just didn't have those sensors on them. Like, there was no pressure sensor, there was no humidity sensor, only on the newer updated cubes. You get back to data from those cubes when you get to the light. So if you go to the light tab, now you'll start seeing some data from cubes 1 through 3 again. Now cubes 4, 5, and 6, the light sensor that they were using was actually a UV sensor that claimed that it also detected visible light and infrared light. I don't know what the issue was here. I don't know if it was just that they were not very sensitive or if they were wired incorrectly. I'm not really sure, but you can see the orange and the green lines here are just pretty like static. It's just the same readings for the most part all the way across. So they didn't really collect very good data. However, the light sensors that we used in the workshops, those photoresistors, they did work. They seem to work pretty well. So you can see the blue and the pink are from those. That's cubes 1 and 2. Cube 3 was another one of those backups that stayed inside of the case, which is why they don't have any you don't see any data from 3 because it was just 0 the entire time. It was actually in the case upside down so that everybody had access to the power buttons, which are on the bottoms of the cubes, and so it never saw the light of day. Even when the case was opened up, it was on the underside of the cube, so it was just dark the entire time. But 1 and 2, they did collect data. Now, as I was saying before, when you look at data, sometimes you wind up having more questions than you have answers in some situations, and this is one of them. So something that we noticed was when the cubes were out and they were velcroed to the walls of the plane, there's these dips in the light, and they seem to follow the parabolas that the plane was making throughout the zero G flight, which doesn't really make sense. Like, why would movement affect light? Now, we have a couple of ideas. I think that the most likely idea was that um, as the plane was doing the parabola, maybe it was moving through different cloud layers. And so as it was going through the clouds, it was like getting dark, slightly darker inside the cabin. And then as it would, continue that parabola and go back down again, maybe it went back into the sunlight. We're not 100% sure, but that is one theory at this point. And then you see where everything is kind of crazy looking here. That's when they were removed from the walls and they were kind of free floating, moving in all different directions. So as the cubes were spinning, they were probably being exposed to light in different ways, or they were facing towards the light or facing away from the light. And so that's why the data looks like that in the middle there. And then they were put back up, Velcroed back against the wall again, and you can see that they're following that same pattern where they dip depending on if I'm guessing if the plane was in direct sunlight or not. So yeah, so feel free to use this data in the classroom. You can see graphically, what these CubeSats pick up, and we'll have similar looking data. Well, not parabola wise, but we'll have graphs and things like that for the Blue Origin launch.
No, something I'm seeing in this data now too. When we started this flight, there were Martian parabolas, and then for Martian gravity and then lunar gravity also. I think that was a Karen, right? Didn't we do the Martian first and then the lunar afterward?
Yes. Yeah, we did 2 Martian and then we did 3 lunar.
And you can see that the data at the beginning of the flight is different than once they were just put back on the wall in the normal parabolas,
Right.
So,
right.
Yeah.
Yeah, all sorts of interesting features of this data for sure. So yeah, so that's available to you. Take a look at it if you so desire. That's it that I had to present, at least. At this point, what I want to do is, if you have any questions, or if you're having difficulty with your projects, or you need some troubleshooting help, please go ahead and ask. Leah, here's the link again, if you want to look at that. And I'm also going to email this out so everybody will get all the links to the presentation and the data and everything.
Noah, this is Jim. I have a question about the Arduino. I noticed in your table format for all the different cubes and the experiments, they're all nanos?
Yes. We're going to be using the Nano Every, which is, I've got one right here. This guy.
Yeah, mini. So I had done my initial design in code writing for the Uno. Should I update that for the Nano?
I don't think it'll make a difference. It shouldn't make a difference. In my experience, any code that'll run on an Uno will run on a Nano as well.
Okay, so with regards to the code and the size of the code and how much it takes up of the memory, are we trying to get that down?
No, so this is actually a really interesting thing about the difference between the Uno and the Nano. The Nano has more memory and has a more powerful processor on it than the Uno does. This, even though it's this much smaller, it's more powerful, which is part of the reason why we're going with it. Number one, to save space and weight, but also because it's just a much more powerful microcontroller. So no, you don't have to worry about making anything smaller or worrying that it won't run on the Nano. If it can run on an Uno, it can definitely run on a Nano.
Okay.
That's just like, every year computer chips get smaller and more powerful. Like this is exactly that concept in action. They're actually even cheaper as well. So like if you go on the Arduino website, arduino.cc, and you try to buy an Uno directly from the source, they're like $24, whereas the Nano is only $11. So it's pretty much better in every single regard.
Jim, I'm wondering, one of the things that we ran into in fixing the data or analyzing the data is, it was not delineated. We couldn't just drag it. Noah came up with this algorithm that did something to the data so we could put it into the spreadsheet, right? Noah, you had to do.
Yeah, I kind of did a roundabout way of collecting the data to the SD cards. Going on into the future, I'm going to do it so that it just kind of spits it out as CSV, or comma separated values, and it should be way easier to copy the data from the SD card right into either Excel or Google Sheets. Since the zero-G flights, I mean, I had to spend a lot of time like reformatting the data to get it to be able to easily get put into an Excel file and then make graphs out of it. So that won't be a issue in the future, Jim.
Okay. All right.
And I'm gonna have all of that available to everybody so that you can see, or even if you want me to do like a one-on-one with you or your class, I can do that as well. Just if you have any questions about how to write the code for the SD card in order to make it so that it saves it to the card in that CSV format.
So, Noah, what exactly do you want from us? Was it the 15th?
Ideally, you'll have a completed engineering model that works and collects data, and you could send us that data. And I mean, even pictures would be cool too. We want to see that you have built a working model of your experiment.
How intense do you want the data?
I mean, what
As close to sort of like simulating, conditions as possible, or
No, it doesn't have to actually simulate, what it would be like on the rocket. Just to show that your code works, that it collects the data, that you can get it off of the SD card. Essentially, it's proving that everything works as it's intended. And also your sketches. At that point, if you could send me the code itself, that way, when I build the actual flight-ready models, I can use your sketches as the basis for kind of the unified sketch that will be used on the actual flight. Because essentially what I have to do is I have to take a bunch of different experiments that each have their own individual sketches, and I have to put it all into one single sketch so that it'll run everything. I mean, regardless of whether or not everybody provides me with that, I'm going to have to do it anyway. But it'll make my life way easier if I can, kind of work off of a blueprint that you guys have already made.
do you have a code file naming protocol you would prefer?
No, maybe just like your name,
Okay.
so I know whose is whose.
And if we send an update, like we figured out that, we can make this better, or we didn't have the right frequency of readings or something like that, how do we handle sending those updated codes to you?
You just email them to me. Just let me know
Something
that
that-
you made an update to it.
Something that makes that a little bit easier, Jim, if you would include like the date that you finalize that code in the name, like today, 12/8/22, 12.8.22, and then because I know I've gone in situations where you're getting all these programs and they're saved the same way, and you can't remember which one is the current one.
Oh yeah, yep.
So a little date tag on there sometimes really helps out.
Yeah, or even if you want to put like a version number, like version 1.0 and version 2.0 or 2.1, whatever it might be, as long as it delineates the differences between your code, that's fine. It could either be a date or a version number or whatever works for you.
And you'd like that by next Thursday, a week from today, you think?
Ideally, throughout this entire program, I mean, I haven't been, too strict on the dates. For anybody who's not here and who's watching this video on YouTube, if you're still at the logical design portion, we're not going to say like, no, you can't participate in this program. But we are kind of finalized as far as the sensors that we're going to be using. We don't really have time to order more sensors and include those. But I think that the sensors we have currently definitely cover everybody who has submitted, a logical design and a physical design at this point and wiring diagram. Everybody's stuff should be there. As a matter of fact, Jim, I actually just got the magnetometer and the current sensor just yesterday. Actually, got them right here.
Okay. Do you want me to send? Because I wrapped a coil wire. Do you need one of those?
If you could just send me the specs on that, like what kind of wire is it? What is the length of the wire? How did you wrap it? That would be helpful.
Okay.
Does anybody have any other questions, comments, or concerns?
I just feel like totally lost in this whole thing still, so I'm sorry. I haven't got my, I haven't been able to download that library I had emailed you about for the Geiger counter yet. I can't figure out how to get that part to work.
Okay.
So and I can maybe like get with you some other time to talk about that. But if you're saying, I was also concerned about the part with the Uno and the Nano. I had done everything to this point, like my wiring diagram, and I was doing it for the Uno, and I have my one Uno from last summer, but I bought Nanos to do with my kids for all the reasons you've talked about.
Right.
But I have been concerned about, like, I haven't found anything like the wiring diagrams and all that kind of stuff. I've only found it for Unos and not Nanos, so I don't.
So the thing about an Uno and a Nano is that all of the pinholes are the same. So like pin 3 on an Uno has the exact same functionality as pin 3 on a Nano. And so what I can do to maybe help you out is I'll send you the actual pinout diagrams. There's pictures that show you where every single pin is on each of the boards. And so you could just match them up. So whatever you did on the Uno, you just use the exact same pinholes on the Nano, and it'll work the exact same way.
Okay. I also, so we need to send you, so right now, what's due next week is the working thing. Is it okay if I just do, like, the Geiger? Right now, I'm just trying to get the Geiger counter to work, and I haven't got that to do that. Is that essentially what I need to do? I have, like, the whole adding the SD card part with it. I don't know how to get all that to work to get the data off and everything. Kind of like what you were saying. I don't know how that part works.
Okay.
Or if you could send me the part, you could send me the code part for how to do that.
Sure.
I did get a couple of the SD, like a couple of more SD card things to use. But that whole part confused me. I don't know.
Well, let's set up a time. Yeah, let's set up a time that we can meet. We can do a Google Meet or a Zoom call, and we can go through all of that.
Okay.
maybe next week sometime. I'll send you an email and we'll figure it out. What time works best for you.
And then another thing was, can I order, like, you had said, like, to order, like, the CubeSat little kits, like, I thought last summer you'd said that we could order those for our classrooms, you know, kind of like what you, not all the sensors and everything, but just like
the frame,
and
the frames itself.
Yeah, the frame. Well, I want to be able to 3D print the frame.
Okay.
So I wanted to get the file for that, but I thought you said we could get, like, you know, those little boards that you screw into.
These guys here.
No, I got the breadboards.
Oh, you're talking about the actual
like
plates.
one was red, like the battery set on one board, and then
these guys.
Yeah, those.
So what I would actually recommend is just 3D printing these.
Okay,
you can
that's fine too.
Yeah, you can
Yeah,
3D
that's
print
awesome.
these, and we have the file for that is on the website with the files for the frames as well.
Stephanie, I 3D printed those.
Yeah.
Okay, no, that's perfect. I didn't know that we had the file to do that.
Yeah, these they're called plates. So if you see the file labeled plate, that's which one you want to print out.
Okay.
And it's like a super easy thing to print. It doesn't use a lot of filament. It doesn't take a lot of time. These were like custom ordered, but I'm not even using these. So for the actual flight ready models, I printed up these plates. These are what I'm going to use.
Okay, that's perfect. I'd rather do that anyway. That'll be cooler, you know.
Yeah.
I mean, for the kids.
Yeah, and it'll probably be cheaper and easier and better in every way.
Then do you have would you have like a set thing of like, what do I need to buy for like screws, like?
Yeah, I can provide that. If you still have it, I'm not entirely sure. I know it was a thing that was easily lost from the workshop, but in your cube frame kit,
I do have that. Yep. Does it have?
There's all the parts there.
Okay.
So these are all the hardware.
So I could like take that, because this hardware is not my thing. I could take that to like Lowe's and they could I could figure it out, or no?
Maybe. Yeah, I haven't looked in Lowe's. I'm sure they probably do. Amazon also. Like, you can order all of this off of Amazon. You can literally just type in these different various types of hardware. And it looks like Jim Lanke just put a place to buy the standoffs.
Probably not most economical, but it is from Adafruit, and those are the M2.5s.
What does standoff mean? Sorry.
Those black parts, those that you screw together and you put the plates on, those are standoffs.
Okay.
So for the actual flight ready to use, I'm not even using standoffs. I'm using these threaded rods. And so how this will work is these plates, maybe you can't see it, but there are screw holes in there. And so these are going to go on there, and then they're going to be held together with little nuts. So, but for what you guys are doing, using the one use, just use the standoffs. That's probably the easiest thing you can do. Any other questions?
Okay, so just we're gonna get it working. We're gonna send a picture of our working thing.
Mm-hmm.
We're gonna send you the code.
Yep.
We got it to work, and then we're gonna send you the data that we got from the code.
Yes.
And my one other thing was, do you have any suggestion? I have been trying to figure out some way, hopefully when I get my Geiger counter to work, like, I don't have any way to test my, we were going to build something to put around it. So I obviously need to send you like what the materials are and everything that we do for that. But I don't have it. How do I test if it works or not? Like,
so there are options. You could purchase some sort of slightly radioactive material, like uranium glass would probably work.
That sounds dangerous, but okay.
No. It's not. It's like there's a lot of things out there, a lot of materials out there that put off such a low amount of radiation that you would get more of a dosage from standing out in the sun, probably.
Smoke detectors.
Yeah, smoke detectors have a little bit of radioactive material inside of them. That's how they work.
So just putting it close to a smoke detector to see, and then put my shield on it, put it close to a smoke detector
Exactly.
and see what the difference is.
Yep. And there may even be just ambient radiation around you that, you can leave the Geiger counter out, collect some data, and then wrap it with your material and see if the reading is less.
Okay.
But yeah, smoke detector would also work.
Okay. So like closer to the smoke detector should have more radiation than farther away.
Right.
Okay.
I would think it would have to be kind of sitting on top of the smoke detector. It's a alpha emitter, so it's not going to go very far.
Okay.
I always used to talk about microwave ovens giving off radiation.
No, I don't think they actually do.
You have the cage over it now, right? I mean, you got.
But even still, those are microwaves.
Jim, right? Come on.
I know that it was definitely like a big thing for a while, and I remember as like a kid when I was in Boy Scouts, we actually we were going door to door selling these little magnets that you're supposed to put on the outside of your microwave, and if it like lights up, you know that it's emitting radiation. But I'm pretty sure that's all been debunked at this point. Microwaves are not the same as radiation, not like gamma radiation at least, or ionizing radiation. I mean, if you put the Geiger counter in the microwave, you would definitely get some sort of result. But I would not recommend that whatsoever. That would be a very bad thing to do. So yeah, I would. You can either you could probably even buy it right on Amazon, some sort of radiation emitting material. Like I know that in like chemistry classes, they do stuff like that. Well, let's see.
Stephanie, do you have any like old crystal china that's red?
It has radiation?
Yeah, the red comes from uranium.
Not work.
My grandmother does. I mean, there was like red on her china.
Yep.
Maybe I could see if I could.
That would be a pretty cool test.
The glass has to be red.
But it has to be like made a long time ago, probably. This is from like older, any kind of china with red on it.
As long as the glass is red and not painted on it. Yeah.
So I know that one of our board members, Joel, he's big into uranium glass. It's just like something that people collect, and when you put it under black light, it glows. And you can buy it all over the place. I know that he's got a pretty big collection.
At the workshop up in Maine, he found some that was green, a kind of greenish yellow color. He identified as uranium glass also.
Yeah, I think
you can something I could like buy on Amazon or something.
Yeah. Yep.
Okay, because that would have like a cool factor also, which is kind of what we're going for as much as possible.
Yeah.
Yeah, an old Fiesta ware. Fiesta ware from like the 50s and 60s, and that's pretty ubiquitous. You can get that pretty cheaply. You can get a plate at an antique store for just a couple of bucks.
Okay. Well, these would all be just experiments in themselves, so that would be awesome.
Yeah, for sure. Yeah, and I think that just seeing if you could find any ambient radiation might be interesting as well. My wife, the high school she used to work at was built on an old Superfund site, courtesy of Monsanto Corporation. And I imagine if you brought a Geiger counter in there, you would not be too happy about the readings that you got. They had like some sort of like crazy elevated number of cancer patients from people who worked at that school for many years. So hopefully your school is not built on a Superfund site.
Okay, thank you.
You're very
Definitely, I
welcome.
just dropped into chat, something I found on Amazon.
Mhm.
Oh, thank you.
Yeah, there's a lot of people. They have big collections of uranium glass. I know that Joel is big into that.
It's not something I know anything about. It's just what the kids thought they wanted to do. So I'm trying to do what they're interested in. So
That is the entire goal of this entire program is
Yeah.
get the kids
I
thinking
know
about
nothing
that kind of
about
stuff.
it.
All right. Does anybody else have any questions? All right. So yeah, if you have any questions that pop up, please feel free to send me an email. I can organize face-to-face conversations like this with you and your students. If you're watching this video on YouTube, please feel free to reach out. And if you have any questions or need help troubleshooting, I'm available. All right. Really excited about all this. Looking forward to seeing your experiments in action and seeing some of that data. So good luck and have a good holiday as well.
Thank you.
You're welcome.